Hi, Drafting 30. We're going to take a quick look at dihedral angles between two planes. Now this is the case where we've got two planes that are joined together, and we're interested in the angle between those two planes. Maybe if I can hold it up like this, we can see there's the angle of one edge coming in to the other edge. Now depending on the perspective that we're seeing these two planes, we may see some kind of an angle, but to measure that accurately, we need to have an edge view for both of these planes. This is actually a little trickier than you might expect, but something like this where we have an edge view of one plane over here and an edge view of another plane over here, then we know that the angle between them is that dihedral angle that we're looking for. Now the technique I'm going to show you on the computer in just a second, one key thing that we need to identify right off the bat is which edge is joining the two planes, right? If I were to expand this out, we can see that I've got 5 edges. I've color-coded them here. I've got 4 purple edges that are on one plane only, right? 2 are on my bottom plane, and I've got 2 on my top plane. And then my 5th edge that I've highlighted in red is the edge that joins the two planes together. And sometimes we talk about this as a fold line or a seam between the two planes. And the key for us is actually we want to first be able to view that as a true length. Remember, if we're viewing a line as a true length and then we do a 90-degree rotation on a perpendicular reference plane, that's going to make that true length line look like a point. And when this, I'm going to try to line this up if I can, when that true length line looks like a point, we'll have an edge view of both of these planes, which is basically the only rotation where we can accurately measure that dihedral angle. So those are kind of our 2 steps. First is identify this true length horizontal line, and then once we have that, rotate our object so that that true length line is basically exactly lined up with our perspective and viewed as a point. And that will give us an edge view of our 2 planes. Now, if we look at this example, this is the first example from our practice pack. There are 4 that we're going to try right off the bat, and I would encourage you to follow along for this one. Now, let's see. I think I've actually got a pretty accurate representation of what we're doing in the example here. And so for me, I can see that the edge in AutoCAD that I'm interested in as the fold line is the one that I've just selected. And so particularly at the start, I think color coding that maybe isn't a bad idea. And if I follow these lines straight up, I can see that it's connecting here and it's connecting here. So this must be the same line in my top view, horizontal plane view. Okay, so that's the first thing that we want to do. Now, as I mentioned before, we need to get a true length of this line. Now, in the bottom view, this is not a true length because we know we can check by looking in an adjacent view and seeing is that line parallel to the reference plane. And since this red line here is not parallel to the reference plane, I know that this, in my frontal view, is not a true length of that fold line. However, if we look at our top view, our horizontal plane view, the reference plane and the adjacent view of this line are parallel to each other, so that actually tells us that this is a true length of that line. So this is a simple example in that sort of step 1 is given to us. We're provided with the true length line right off the bat, and we know that we can solve this just like we have in all the previous examples. This part isn't new. Now, to get the dihedral angle, we just need to turn this horizontal true length line into a point. And to do that, we need our perpendicular reference plane. Now, to do that, I'm going to use the Universal Coordinate System, UCS command, and I'm going to say, let's remap the UCS to this direction. That's just going to let me easily create parallel and perpendicular lines. And so let's create a new reference plane. So my 90-degree now is perpendicular to that true length line. So I'll make my reference planes in purple, and I'm going to color coordinate these points that I'm projecting forward. Maybe I'll just move this a little bit closer. So let's use teal for this first one. That's fine. And so I've already got it projecting up to my top view, and then let's go at my parallel line 0 degrees with this new coordinate system, and we're just going to work our way for each through each point. So actually maybe let's color code these, and we'll do the same thing for my yellow line, and turn this to be orange. And we'll also project a line from there across. And then lastly, if we look at this teal, this is sort of a good self-check to make sure that things are correct. If I try projecting this line parallel, we see that it is basically in line with that line we just created. And so we're taking 2 points, we're projecting them to a single point because they're in line with that new rotation. So basically a plane that's rendered with 4 vertices, if we're showing it as an edge view, is going to actually only have 3 different vertices from that perspective, which is what we are looking for and what we have here. Now, in order to project these dimensions forward, I'm going to use the auxiliary method where I'm skipping a view, I'm going to measure, then I'm going to project forward. So I'm just going to measure using the circle tool. So I'll measure from my reference plane and move that circle to my new reference plane. That's giving me this intersection moving forward. And I'll repeat that process for my yellow line. And I'll repeat that process for my orange line. And if I switch back to the 0 layer, I now have 3 intersections. I've got an orange-orange intersection that I can connect to my teal-teal intersection, which I can connect to my yellow-yellow intersection. So this is my edge view of both planes, which gives me access to measuring the dihedral angle between these planes. So if I were to want to complete this question, I could use the angle tool, and it's telling me that the angle is 73. So I may just go over here, double click to edit the text, and say that it's 73 degrees. Alright, and maybe just since I'm done this, I'm going to say UCS, and then world lets us reset to our standard Cartesian coordinate system. Alright, so we'll do some practice with this, and good luck.